Hello, my name is Elijah Potter, and I'm a data scientist at a real estate tech company called SkySlope, and I'm currently enrolled in the graduate program for data science at SMU. Recently, you tasked our team with analyzing your car dealership data with the goal of constructing a time series model to predict future vehicle orders. We've made some headway on this project, and I want to provide an update with our preliminary analysis and findings. To start with, here is the data that was provided to our team. It includes a series of behavioral metrics as well as the number of private vehicle orders per day. In an effort to gain an understanding of this data, we set out to identify existing relationships between these metrics. While this is not majorly impactful on our simple time series models, we want to ensure that we're not utilizing potentially redundant predictors when constructing multivariate models. We can see here that there exists evidence of potential correlation between sessions and configurables finished, test drive requests and online lead counts, and dealer locator uses and total configurables finished. We will make sure to keep these correlations in mind when constructing more complex models going forward. So for now, we'll take a look at the private orders time series. Our realization here, we can see plenty of wandering behavior without any obvious signs of non-stationarity. We can see some anomalous peaks that may relate to dealership sales or holiday events. And here our spectral density plot shows us some evidence of wandering with a peak around 0, as well as peaks around 0.14 and 0.29, which correlate to potential weekly and bi-weekly trends respectively. For our first attempt at modeling the vehicle order time series, we constructed an ARMA 6.4 model presented here in zero mean form. This model has an AIC of 7.26 and a white noise variance of 1366.11. So we then performed two forecasts. Here's a short-term forecast using this model and a long-term forecast. We can see that in the short term, our ARMA 6.4 model has an ASC of about 1603.29. And in the long term, the model has an ASC of about 559.48. Alternatively, the rolling window RMSC for short-term forecasts is 1644.46, and the RMSC is 2104.16 for long-term forecasts. It is important to note that these metrics are generally useful for comparisons of separate models. So next, we're going to investigate a time series model with a seasonal component. For our second attempt at modeling the vehicle order time series, we constructed an ARIMA 905 model with a biweekly seasonal component of S equals 3. So the model here is presented in backshift notation. We can see it has an AIC of 7.33 and a white noise variance of roughly 1444.5. So again, we performed two forecasts. Here is a short-term forecast and a long-term forecast. We can see that in the short term, our seasonal ARIMA 905 model has an ASC of 2005.94, indicating that it performed suboptimally when compared to the ARMA 6.4 model. But in the long term, the model has an ASC of about 536.74, which is actually a slight improvement over the ARMA 6.4 model. Alternatively, the rolling window RMSC for short-term forecast is 1906.86. And the RMSC for is 2565.26 for long-term forecast. It should be noted that both these rolling window comparisons indicate that the previous ARMA 6.4 model may be the more ideal model. So what's next? The next steps in our analysis include the construction of multivariate models. While we can model the sales time series in a vacuum, like we did earlier, it stands to reason that other factors, such as consumer behavior, have a meaningful impact on vehicle sales. So to do this, we're going to utilize VAR, neural network, and ensemble techniques to build a series predictive time series models and identify the ideal solution for predicting vehicle sales. So I just want to thank you for your time, and I look forward to our next presentation. Thank you.